All right, go ahead and excuse the dog in the back that's barking. Number 30, we've been told to solve by taking square roots. And we already have hint. Hang tight. Okay. Our hint here is to get x squared by itself. So just like we did in like 27, 29, we're going to solve everything out to get x squared isolated or by itself. So the first thing I'm going to do is subtract 5 to both sides. That's going to leave me with 230. My next step is to divide out the 10 that's multiplying with x squared. So when I divide 10 to both sides, I'm left with x squared equals 23. And now to get x by itself, we're going to take the square root of both sides. The square root undoes a squared, and that's going to give me x equals. Now 23 is not a perfect square, so we can't take the square root of it. So we're going to just leave it as square root 23. And we say plus or minus because when we're working with taking square roots in an equation, there's a positive value or a negative value. So this would be our answer here. In 31, you give me a second to delete this out, and I'll just go back over it. Completing the square, we are trying to create a condition where we have a trinomial, so 3 terms, and we are manipulating the equation so that the 3 terms, when factored, would turn into a binomial squared. So the way that this works is the first thing we want to do is we want to get rid of this 55, so we're going to add it to both sides. Our C term, right? When I talk about A, B, and C, we move our C term by adding 55 to both sides. Once that's done, what we're going to be able to work with now is x squared minus 6x. I'm going to say plus blank. I need to use a specific number there. And if I use that specific number right here, then it will turn this into a binomial squared. Think about an equation being like a scale. I can change my scale by whatever I want as long as I do the same thing to both sides. So if I have a scale and right now this is balanced, then if I add 5 here, as long as I add 5 here, my scale stays balanced. So here's how we're going to figure out what we use. We're going to take our b term and we're going to find half of it. So we're going to cut it in half by dividing by 2. And then once we've found half of it, we're going to square that value, and that's what goes up here. So negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. Again, this is a scale, so as long as I add 9 to both sides of my scale stays balanced. Okay, what we've done now is we've created a trinomial that when factored, so if we were to factor and we put 9 and negative 6, what we would end up with are 2 of the same numbers on the side, negative 3 and negative 3. And it works every time like that when we're completing the square, when we follow this pattern, divided by 2 and then squared. If you notice, the number we get when we divide by 2, which I just filled in here, that negative 3, ends up being the same numbers that are on the sides. So essentially what that means is that this whole thing I've just highlighted in purple is the same as x minus 3 squared. And then that equals, I'm going to put 55 and 9 together to get 64. So x minus 3 squared equals 64. That's the whole completing the square, is finding this number so that it creates a perfect square. Now we can solve by taking square roots on both sides. That's going to undo that squared, so that x minus 3, I can now get to my x minus 3 equals, and the square root of 64 is positive or negative 8. Because positive 8 times positive 8 makes 64, right? Positive 8 squared. And negative 8 times negative 8 also makes positive 64. So that's why there's 2 there. And so I'm going to now split this because there's a positive value and a negative value. So I'm going to say x minus 3 could equal a positive 8, or x minus 3 could equal the negative 8. And then I'm just going to solve each. So by adding 3 to both sides, I'm going to get x equals 11 here. By adding 3 to both sides on this side, I'm going to end up with x equals negative 5. So those are my 2 solutions.